of yung mga different specimens natin, no, or microbial specimens, no, or this colonial morphology or tinatawag natin na colony characteristics, no, and at the same time, no, yung mga different forms of our different different forms of microorganisms. Okay? No, and of course, no, we also yung mga discuss yung mga specific characteristic nila or yung distinguishable characteristics, no, of different microorganisms, no, for yung presumptive identification natin. So we're going to continue, no, this morning yung ating discussion, no, with regards to colony morphology natin. And of course, no, colony morphology natin, no, as what I've mentioned last time, no, is important siya, no, to provide the presumptive identification of yung mga different microorganisms natin, no, na mention natin last time, no, we're in this procedure, no, usually, no, after 18 to 24 hours, no, dito natin nakikita, no, yung mga presumptive morphological identification natin of different microorganisms, no? So, last time, may nakita na kayong presentation? Ayun. Okay. Okay, noted, Miss Malinaw. We're done with this, no? So, balikan natin siya, no? So, initial observation natin, interpretation natin, no, with yung ating different microorganisms, no? As what I mentioned, usually yung colonial morphology natin, no, is observed, no, usually after 18 to 24 hours of incubation, depending, no, kung anong oras natin siya na i-plant doon sa ating culture media or ay na-isolate, no? So, next is yung ating tinatawag na plate reading. No, in plate reading natin, usually, no, nire-read natin ang plate natin, no. After 18 to 24 hours natin nire-read yung plate natin, no. So, in plate reading, no, usually ito siya yung mga comparative examination of mga colony morphology natin, wherein dito natin, no, tinitingnan yung mga size, no, yung mga shape ng mga different microorganisms natin, no, yung ina-assess natin yung different growth of different microorganisms, no. Meron tayong ginagamit na blood agar wherein non-selective, and yung tinatawag natin na chocolate agar natin selective, no, used for, no, culture of yung mga different fastigious microorganisms natin. And of course, no, another is, no, usually, no, organisms which grow on blood agar plate, no, will also grow on chocolate agar. But then again, no, there are some consideration with this, no. Not all, no, can grow on a chocolate agar, but will grow on a blood agar plate. So, meron tayong tinatawag na gram-negative bacillus, which is tumutubo siya in a blood agar, tumutubo siya in a chocolate agar, and hindi siya tumutubo in our blood agar plate, no. That microorganism is tinatawag natin na Haemophilus, or yung Haemophilus influenzae natin, or yung in general, no, Haemophilus, family of Haemophilus, no, as what I've mentioned last time, no, most of the time, no, yung tumutubo in our chocolate agar, no, is yung ating Neisseria and yung ating Haemophilus, no. So isa siya sa mga example wherein tumutubo siya in a chocolate agar, but then again hindi siya tumutubo in a blood agar plate, no. Si Haemophilus influenzae natin, or si Haemophilus, or yung family ng Haemophilus, no, sa chocolate agar sila tumutubo. So those are that is one of the example wherein, no, gram-positive bacillus na tumutubo sa chocolate agar natin. But then again, hindi siya tumutubo in a McConkey agar and blood agar plate. Okay? Next is yung gram-negative diplococci natin, which grow on chocolate agar but not on MAC and blood agar. So, anong sagot nyo dito, no? Gram-negative diplococci, which grow on chocolate but not on MAC and BAC, na-mention ko kanina a while ago, no? Si gram-negative diplococci. Anong sagot nyo dito? Gram-negative diplococci, which grow on chocolate but not on MAC and BAC. Anyone? Anong organism? Anong organism? Anyone from the group? Anong organism usually yung tumutubo sa chocolate agar natin? Okay, so yung gram-negative diplococci, yes, family of Neisseria natin. No? So usually yung family of Neisseria natin no, is a gram-negative diplococci wherein tumutubo siya in chocolate, but then again, hindi siya mo tumutubo in imac agar natin and blood agar plate. No? O ulitin natin, no? Si gram-negative bacillus, no, which grows on chocolate agar, but then again, hindi siya tumutubo in both mac and blood agar plate is sino? Si Haemophilus natin. And si gram-negative diplococci, which grow on chocolate but not on mac agar natin is si Neisseria natin. So no, on blood agar plate and chocolate agar, no, gram-negative rods produce large colonies that appear gray and sometimes mucoid. And if hemolysis is seen on blood agar plate, no, true hemolysis, no, is not seen on chocolate agar, no. So usually, no, hemolytic patterns of microorganisms is ino-observe natin in a blood agar plate, no. Always remember that one, no. Hindi natin siya ino-observe in chocolate, yung hemolytic patterns of different microorganisms, but then again, ino-observe natin sila in a blood agar plate, no. So hindi tayo nag-observe ng hemolytic patterns in Mat-Conti agar, no? Always remember that one, that yung ina-observe natin in a Mat-Conti agar is yung fermentation, no, of carbohydrates, no? Or specifically yung ating lactose fermentation, no? In a blood agar plate, no, usually dito natin ina-observe yung different hemolytic patterns of our microorganisms. Okay? So I already gave you this general rule, no, for yung ng ating microorganisms, no, wherein all cocci are gram-positive, no, except Neisseria, Villanella, Brahamella, or yung ngayon commonly na tinatawag natin siya na Moraxella. So always remember yung ating general rule, no. Hindi kayo maliligaw dito pag naalala niyo itong general rule natin. Okay, next. All cocci are gram-negative, all bacilli are gram-negative except, no, itong mga Mycobacterium natin, Clostridium, Corynebacterium, no, Bacillus erysipelotrix, Listeria, and Lactobacillus natin. And all spirochetes are gram-negative, no? So always remember yung general rule natin, no? Para later on di kayo mahirapan. Okay? No? So this one, no? Yung ating tatlong plate, usually nyo yung mac, chocolate agar natin, and Mat-Conti agar natin, chocolate, and blood agar natin. No? Usually, no, sila yung pinaka-common natin na ginagamit, no, inside the laboratory. Yung sa upper part, no, kung makikita niyo dyan, that one is yung chocolate agar natin. This one, no, yung by red. And ito siya is Mat-Conti. Makikita niyo naman siya, madidifferentiate niyo naman siya based on color. But then again, there are some instances na mahirapan mag-identify yung iba, which one or which amongst those culture media, yung blood agar and Mat-Conti agar. So always remember, mas darker yung color ni blood agar plate compare kay Mat-Conti agar, no? So ito is Mac, and this one is yung inyong blood agar plate, no? So usually, no, this three culture media, no, ito sila ang pinaka-common na ginagamit natin inside the laboratory. As what I've mentioned, no, usually ang ina-observe natin with chocolate agar natin or chocolate agar plate natin is yung ating Haemophilus and yung Neisseria, no? Always remember that one, no, si Haemophilus and si Neisseria natin, no? Usually tumutubo sila in a chocolate agar natin. Okay? Okay, noted doon sa mga nag-chat, no? Okay, no, next is yung ating Mat-Conti agar or mac, no? So, best used to characterize gram-negative rods, no? Dito natin kina-characterize yung different gram-negative rods natin, no? Especially yung ating ano tawag dito, Enterobacteriaceae, no? Because of their lactose fermentation, no? So, meron tayong mga different microorganisms, no? Na piniferment nila yung lactose. No, once this one, no, yung nandito sa taas, no, that one is lactose fermenters, and yung sa baba is tinatawag natin na non-lactose fermenters natin na microorganisms, no? Okay, so later on, bibigyan ko kayo ng list, no, of different microorganisms na lactose fermenters and yung mga non-lactose fermenters natin na microorganisms. Okay? Next is lactose and non-lactose fermenters. No, usually ito sila is screening of yung mga different enteric, no, but very common ito in our Enterobacteriaceae family. Okay, so nandito na tayo. So usually, as what I mentioned niya last time, ito siya very common natin makikita with E. coli. No, usually dry, no, and large siya na colonies. Usually, makikita nyo in a culture media. No, usually ganyan na ganyan yung itsura ni Escherichia coli once in a McConkey agar. Next is yung ating tinatawag na ito. So usually, no, ito siya. Kung mapapansin nyo ito sa media or sa culture media, usually this one is yung ating Klebsiella. No? Very common ito siya in a culture media natin. No? Usually, ganyan siya. Medyo mucoid siya, na smooth yung kanyang edges. No? Later on, makikita nyo yan in our culture media. Okay, no? So next is yung gross colony characteristics no, used to differentiate and identify microorganisms. So first is yung size, no? As what I mean, hemolysis, no? Or hemolytic patterns, no? Of different microorganisms natin, no? On that agar plate, no? Which means, no? Yung hemolysis, no? Or hemo, from Greek word which is pertaining to red blood cells, and yung lysis natin, or dissolution, or breakdown, or break apart of our red blood cells, no? That is observable in our culture media, no? Kung mapapansin nyo dyan sa picture, no? Makikita nyo dyan sa picture, meron dyan hemolytic patterns, no? Beta, alpha, and gamma hemolysis, no? So usually ito siya, si beta hemolysis natin, no? Makikita nyo siya very common siyang makikita nyo si alpha hemolysis, no? In strep pneumonia. So usually ganito siyang itsura, no? Green discoloration. No, pag binaliktad nyo yung culture plate nyo, makikita nyo meron siyang green discoloration, no? Meron siyang hemolysis, no? Makikita nyo yan siya na parang clear siya na green. No, that one is meron siyang tinatawag natin na alpha hemolysis. So usually this alpha hemolysis can be seen in our Streptococcus pneumoniae and of course in some very dense group natin, no? So later on, no, discuss natin yan kung saan natin sila i-differentiate, no? Paano natin ma-identify that one is Streptococcus and that one is very dense, no? Meron tayong mga different tests na ginagawa. Okay, next is yung ating beta hemolysis. No? So usually si beta hemolysis or complete lysis of the RBC, no? So most of the time na makikita nyo itong si beta hemolysis, no? Ito sila lahat, yung mga surrounding naman ng growth, no? Usually nagkakaroon yan siya ng lysis, nagkakaroon ng clear na lysis, no, under the specimen or under the growth or under the isolate, no? So usually this beta hemolysis natin is makikita siya in our Staphylococcus aureus, no, Strep agalactiae, and Listeria monocytogenes, no? Later on, no, isa-isahin natin yan siya kung anong itsura nila in a culture media plate. But then again, no, parang almost ganito siya, no? Meron siyang complete hemolysis, si beta hemolysis. Okay? Next is size, no? Size of our different microorganisms. So sabi ko nga last time, no, meron tayong small, pinpoint, medium, large. No, this one is mako-consider na natin siya na large growth, no? Yung mga ganito kalaki. Ito sila, pwede na ito silang pang pinpoint, no? This one is small, yung mga ganito kalaki. And this one, pwede na natin silang i-consider as medium size of growth of our microorganisms. Okay? So, always remember na meron tayong small, medium, and large, no, na colonies, no, on their size. No? Later on, gagamit natin siya as we go along with our discussion, no, as kung paano natin i-describe yung different growth of different microorganisms in our culture media. Okay, remember that yung size. Okay, next is form, no, or yung tinatawag natin yung form ng ating microorganisms, yung kanyang form or margin na tinatawag, no? So usually this form or margin, no, the edge of the colony should be observed in the form or margin described as smooth, filamentous, rough, or rhizoid, or irregular. No, usually ganito siya pag rough. No, filamentous, this one is filamentous. This one is irregular. Yung smooth, no, makikita niyo yung edges niya. Balikan natin yung picture, no? Ito siya, no? Ito siya pwede nating makonsider na smooth, no? Kasi smooth yung kanilang edges, no? Wala kang makikitang other na form or margin niya. Okay, so next is usually, no, si Bacillus anthracis natin are described as medusa head, no, due to its filamentous appearance. No, this one is example of yung mga growth ng Bacillus anthracis natin, no. Ganyan na ganyan yung itsura ng growth ni Bacillus anthracis natin, no. Filamentous siya, no, in a culture media natin, no, si Bacillus anthracis. Okay, now swarming is a hazy blanket of growth on the surface that extends well beyond the strict lines, no? So example of this is yung Proteus mirabilis natin and Proteus vulgaris on a blood agar plate and chocolate agar plate, no? Usually na nag-extend sila beyond yung ating streaking, no? By the way, usually yung mga microorganisms natin is tumutubo lang sila kung saan lang tayo merong streaking, no? Always remember that one, no? Pag may nakita kayo na tumubo outside yung streaking niyo, magdadalawang isip na kayo, contamination yun siya, no? Always check, no? Makikita nyo naman yung daan ng inyong streaking, kung saan kayo nag-streak, no? So always remember that one, no? Na to check, no, every now and then. Ayan, malinaw na. Malinaw na or choppy pa rin. Okay na, Mr. De La Pina? Okay. Okay, no? So, next is yung form niya, no? Or margin, no? So, usually si Proteus, always remember that one na most of the time, no, merong characteristic na ganun. Always remember that si Bacillus anthracis are described as medusa heads, no, due to its filamentous. And of course, no, si Proteus, no, always remember na swarming si Proteus, no, yung form or yung margin ni Proteus, okay? So, always remember that one, usually lumalabas yan siya sa board examination. Okay, form or margin. Next is yung produce yung the pteroids natin produce colonies that have rough edges, no? And yung mga yeast natin produce colonies that are described as stars or colonies with feet or pedicles, no? Usually, no, kung mapapansin nyo dito sa plate na ito, meron siya, etong iba, hindi ito sila yeast cells, but then again, yung mga ito, yeast cells din siya, no? So later on, no, as medyo matagal na kayong nagtatrabaho as medtech, ma-identify niya yan siya if that certain growth is yeast cells or hindi. Ano? Mag-develop lang yung skills na yan. Okay? Now, next is yung elevation of our growth. Now, mayroong different elevation time na tinatawag. Now, first is yung usually, no, elevation elevation may be raised, convex, flat, or umbilicate, no? Depressed center, concave, no? Or umbonate, no? Raised or bulging center, no? Convex, outy, no? Ibig sabihin, no? Strep pneumoniae, usually yung streptococcus pneumoniae natin typically produces umbilicate colonies, no? Unless the colonies are mucoid. But then again, no, most of the time, si streptococcus pneumoniae natin, yung kanya growth in a culture media most of the time is mucoid siya. Next is yung Streptococcus aureus naman natin typically produces convex colonies. And beta-hemolytic streptococci generally produces flat colonies. So mapapansin nyo naman, makikita nyo naman, nalikan natin yung picture dito. Wait, where is it? Balik tayo. Bakit ayaw mo move, no? So, ganito siya, ito. So, usually, pag siya, ganyan lang siya, no? Mapapansin nyo naman yung culture media, no? Flat siya, medyo raised siya ng konti, convex, or yung medyo dome, umbilicate, no? Ganito ang itsura niya, parang may hole siya sa gitna, and umbonate, ganito siya, parang siyang nipple-like structure, ito siya. Tingnan natin ito kung i-identify natin kung ano siyang elevation. Balikan natin. Ito siya. Paano nyo ito siya? I-identify yung elevation niya.
Concave.
Anyone? Paano nyo identify yung elevation niyan? Yung big one. Anong elevation niyan? Is it flat, raised, convex, umbilicate, or umbonate? Paano nyo i-identify ang elevation niyan? Ito first one. How about yung iba? It's, yung iba, anong sagot nyo? Concave or convex? Ano ito, Mr. Bingwit? Yung iba na sagot niyo? Yes, it's convex. No, how about yung second one? Yung nasa pointer. Ano yan siya? Yung may pointer, ito. Paano niyo siya i-identify? Yes, indeed. How about the others? Anong sagot niyo? Okay, flat siya, no? Yung second one, no? Ito siya is convex, no? Or dome, no? Kung mapapansin nyo. And this one is flattened siya or na-flat siya, no? Yung second picture natin. Okay? So, ganyan na ganyan ang itsura nila, no? In a culture media, no? So, tingnan nyo mabuti kasi usually pinapadescribe yan siya, no? In a culture media. Okay, next is yung ating density. No, the density of the colony can be transparent, translucent, or opaque. Translucent colonies allow some light to pass through the colony and opaque colonies do not. No? So usually, no transparent, ganito siya, or transparent to translucent. No transparent colonies, usually, I don't have an example dito, but then again, no, ito siya. No, this kind of mga colonies, no, ito. Yung sa picture kanina na pinakita ko sa inyo. Ito siya, paano nyo ito ma-identify? Ano ito siya na yung density niya? Anong density niyan? Ito, anong density nito? Anong density niyan, guys? Transparent, translucent, or opaque? Ito, density nito. Yes, indeed. Pag translucent siya, medyo parang mas lighter siya nito yung growth niya pag translucent siya. No? Pag transparent siya, yung nakikita niya siya, no? Or nagpa-pass through siya yung light through yung growth niya. No? Later translucent. Okay? So, yun. Next is yung kanyang color. So, usually, nag-vary yung color ng mga different microorganisms natin, no? Okay, noted. Pinahama ka ng iyong alarm. No, it's okay. Okay, noted. Doon sa mga nag-chat. Okay. Okay. Now, so balik tayo color, no? We have different color of yung ating colonies, no? Maybe white, gray, yellow, or buff. No, usually, no, colonies most of the time, no? Yung color ng colonies natin most of the time is white. Wait lang. Okay, noted. Okay, most of the time, no, yung color ng colonies natin is white or gray or grayish white. No? So, color of colonies may be white, gray, yellow, or buff. No, usually it's either grayish white, no, or white or gray. Or that's why natin describe natin sila as transparent to translucent, grayish white, or opaque white, grayish white. So, ganun natin silang dinedescribe, no? Coagulase negative staphylococci are white, no? Certain micrococcus species and Neisseria, non-pathogenic species of Neisseria are yellow or off-white. No, gram-negative rods, no, are gray on blood agar plate. No, so usually this color of different microorganisms, no, is ino-observe natin, no, in a blood agar plate natin, no. Ito siya, no. Anong color nito? Tingnan natin kung hindi tayo colorblind lahat. This one, anong color niyan? Anong color niyan, guys? Kung hindi tayo colorblind lahat. Indeed, white siya. So, hindi pa naman tayo colorblind. No? Okay, next is yung consistency ng growth ng microorganisms natin. Yung consistency is determined by touching the colony with a sterile group, no? Or minsan, no, nakikita naman natin sila without touching yung growth ng colonies natin, no? So usually, colony consistency may be brittle, no, or splinters, no, creamy, dry, or waxy, no? So usually, ganun siya dinedescribe yung consistency ng ating microorganisms. So how about this one? Paano nyo i-describe yung consistency nito by looking at it? Paano nyo i-describe yung consistency niyan? Etong growth na ito. Anyone? Paano nyo siyang i-describe yung consistency niyan? Lola, growth na ito. How are you going to describe this one? Is it creamy? Dry? Paano nyo i-describe? Is it creamy, brittle, dry, waxy? No? Paano nyo siyang i-describe itong growth na ito? Anyone? How about yung iba? Anong sagot nyo? This one is creamy and ito siya, no, medyo dry na ito siyang isa, no, yung mga small, no, yung mga pinpoint colonies natin. Ma-consider natin this one is a dry form of colonies natin, no. So usually ganyan ang kanyang itsura, no, dry siya na klase ng colony. So ganyan usually yung dry. And of course, no, si E. coli natin, no, is kung naalala niyo kanina yung picture na nakita ko sa inyo, no, wherein si E. coli natin is dry colony siya, no, nabilong siya doon sa mga colony na dry siya. And si Klebsiella pneumoniae natin naman is makonsider natin na creamy, no? Okay? Okay? Next is, no, colony consistency may be brittle, no? As what I mentioned nga, no? Paano nyo malalaman na brittle siya? Nung itatouch nyo lang siya ng sterile loop natin, no? Malalaman nyo na if brittle or hindi yung inyong mga colonies. And of course, no, Neisseria species, usually, no, sticky siya, yung mga nocardia species natin. Those are specimens or those are microorganisms, example of microorganisms that are brittle, crumbly, and wrinkled, no, resembling breadcrumbs on a plate. No? Those are nocardia. And the keroid naman natin, no, dry and waxy. No? So yun sila, no? Usually, ang itsura nila under the or on our culture media plate. Okay, no pigment. No, we have different pigment na present in our culture media. No, mayroong mga different pigments yung ating mga microorganisms. So pigment is a production. Pigment production is an inherent characteristic of a specific organism confined generally to the colony. So for example, no, si Pseudomonas aeruginosa natin or P. aeruginosa natin, usually meron siyang green, sometimes a metallic sheen pigment, no? This pigment is tinatawag natin na pyverdine, pyocyanin, or pyorubin. No? Those are some terms na ginagamit sa pigment ng Pseudomonas aeruginosa natin. Next is si Serratia marcescens, no? Usually brick red, especially at room temperature, or tinatawag natin na protegusin, no? Yung kanyang pigment ni Serratia marcescens, okay? And si Cloibera species, no? Usually color blue. In Chromobacterium or violatium, usually purple or violation ang tawag sa kanyang pigment. And of course, no, yung Provitella melanogenetica natin is usually brown to black yung kanyang pigment. Okay? Wait. Okay, so yan, usually, no, makikita nyo. Those are, ito sila, no, kung mapapansin nyo, kung makikita nyo dyan, mayroong mga different pigments of our microorganisms, no? But later on, pag dumating na tayo doon sa mga specific microorganisms natin, no, isa-isahin natin yung mga different pigments natin, kung ano yung itsura nila, pagkakita natin sila sa ating plate. Odor, next is odor. Odor should be determined when the lid of the culture plate is removed and the odor dissipates now into the surrounding environment. No, usually, no, since Staph aureus natin, usually old stock on MSE, no, kung aamoy niyo yung mga paa niyo dyan, no, so yan usually yung amoy ni Pseudomonas aeruginosa on mannitol salt agar. No? Si Pseudomonas aeruginosa, fruity or grape-like. No? There are some instances na yung mga wound discharge, no, maaamoy niyo siya na medyo fruity siya or grape-like. No? Or minsan nag-greenish siya due to yung pigment ng Pseudomonas. No? Mas madali itong i-identify si Pseudomonas aeruginosa natin in the plate and of course in a specimen. There are some specimens na kung mapapansin nyo minsan, no, medyo fruity yung amoy or medyo grape-like and medyo nag-greenish siya. So magsususpect na kayo na that certain specimen, most likely, no, meron siyang positive siya for Pseudomonas aeruginosa. Okay, noted dun sa nag-chat. Okay, next is, no, 2-aminoacetylphenol, no? Next is yung Proteus mirabilis natin or yung putrid siya pag inamoy natin si Proteus mirabilis natin. Medyo matapang itong amoy ni Proteus mirabilis, no? Later on, pag naamoy niyo siya, no, amoy pa lang, alam niyo na Proteus siya, no? Later on sa laboratory, no, hindi kasi natin siya magpa-perform and seldom na tayo makakapag-isolate ng Proteus. But then again, no, sa SPMC, no, meron silang mga ganyan na-isolate at maaamoy niyo talaga kakaiba ang amoy ni Proteus, no? Usually, no, next is Haemophilus species natin, mousy basement, mousy or mouse nest smell, or usually para siyang Zonrox or Clorox-like yung amoy ni Haemophilus. That's why, kung mapapansin nyo, mostly, yung mga chocolate agar natin is inaamoy-amoy natin. No? Or inaamoy-amoy ng mga medtex. So, huwag kayong magtaka bakit inaamoy-amoy nila ang medtex. So, dapat test nila if meron siyang presence of proteus, or ng Haemophilus influenzae, or yung mga Haemophilus species natin. No? Nocardial species, usually ang amoy ni Nocardial species is freshly plowed field. No? Amoy lupa si Nocardia. No? Yun ang distinct characteristic ng mga different microorganisms, based on their amoy. Okay? No? Next is yung colonies with multiple characteristics, So usually, there are some colonies na meron silang mga multiple characteristics on a culture mediately. Now, Bacillus cereus forms large, rough, greenish, hemolytic colonies on blood agar plate. Ito siya usually si Bacillus cereus. Large, rough, kung mapapansin nyo yung edge niya, hindi siya smooth. Kung titingnan niyo siya, hindi siya smooth, yung edges ni Bacillus cereus. Large siya, and meron siyang greenish, hemolytic colonies on the blood agar plate. Next is Echinella corolliens, forms small, this one, fuzzy edge colony with an umbellate center on blood agar or chocolate agar plate. Kung mapapansin nyo, meron siyang umbellate, in the middle, umbonate, center on a blood agar plate. So that's your Echinella usually. Very common siya in our Echinella. Okay? Next is yung ating growth of organisms in our liquid culture media. Masakit ang aking singaw. Okay, streamers or vines and puffballs are associated with certain species of Streptococcus. So usually, excuse. Okay, so usually nakikita natin ito in tube media, Usually growth nito in TSI or in TSD or in a high-blade collate natin, So usually ganito siya makikita niyo, yung organisms, ganito siya ang itsura niya, And of course, there are some meron silang mga pelical formation, especially in ACSF. Now we're almost done, Next is yung turbidity, which refers to cloudiness of the medium resulting from growth, and usually gas if the medium contains glucose. Usually, turbidity, ito siya ang very observable na ma-observe natin na characteristic in media natin if meron na siyang growth ng microorganisms, is yung turbidity. This turbidity also ginagamit natin during antimicrobial susceptibility testing natin, working doon sa density, kung maalala niyo pa, doon sa density, yung density, yung measure natin, is kina-compare natin with yung McFarland standard natin. Kung maalala nila pa, kung paano natin i-count yung microorganisms. So, based on density. So, this turbidity is based on the density of the microorganisms growth in a broth natin na tinatawag. Okay? Naalala niyo pa yung density, is kina-compare natin siya yung ating isolate doon sa McFarland standard natin, which is most common na ginagamit natin with our antimicrobial susceptibility testing kasama noong portrait technique natin, and of course yung microscopic examination natin or microscopic na count natin ng microorganisms. Okay, next is yeast and Pseudomonas species produce scum or the sides of the tube. So usually ganito siya makikita nyo, parang meron siyang dumidikit dito sa gilid ng tube. Kung mapapansin nyo, ito siya usually yung itsura ni Proteus natin and, ni Pseudomonas natin and yeast cells in describe that kind of growth in a culture media? Balik tayo sa margin. Paano nyo ito i-describe ang margin nitong growth na ito? Anyone? Paano nyo i-describe yan siya? Paano nyo i-describe itong growth na ito? Before we proceed to next chapter natin, no? Yes, filamentous. Ito, paano nyo siyang i-describe? Paano nyo siya i-describe? Anyone? Para lang alam ko kung may natutunan kayo sa araw na ito. No, paano nyo i-describe? Ito siya. How about yung iba? Paano nyo ito siya i-describe? Or natulog na ang iba dyan? How are you going to describe this one? How about yung iba? Anong sagot nyo? Yung iba, anong sagot nila?
Pink, red.
Ito siya, creamy. Ito sa paningin nyo. Yes, it's a dry umbilicate. Yes, indeed. True. How about ito? Sige nga. Describe from number of growth, papuntang size, papuntang lahat yun kanina. Sige nga. From yung margin, form or margin, from size to form to margin, from number of growth niya, quantitation, yung elevation niya, and of course, yung density, yung consistency niya, and if meron siya presence of pigment or wala. Sige nga. So that alam nating lahat. Anyone? Lahat yun. Size, kasama yun. Pati color. How about yung iba? Kaya nyo yan. Iwala lang. How are you going to assess that one? Paano nyo ibibigay yung mas macroscopic morphological characteristic of this isolate or of this growth? Paano nyo ibibigay? Sige nga. Anyone? Go, kaya nyo yan guys. I'm waiting. Paano nyo yun siya i-describe? I-zoom nyo para makita nyo. How about yung count mo, yung quantitation mo or qualitative quantitation mo, Miss Maliga? How about yung iba? Anong sagot nyo? nyo. Okay, you can type your answer, no? Heavy growth, rough, medium, dry, flat. How about yung iba? I'm waiting for your answers, guys. Kaya niyo yan. Go lang. Translucent, white, dry, heavy growth, rough, dry, white. I-zoom nyo para makita nyo maigi. Para mo sabi nyo that one is rough or smooth or dry or anong kulay niya. Yung iba. Now I'm waiting for your answers. Okay, you can type your answers. Now I'm waiting. Yung iba, anong sagot nila? Heavy growth, rough, flat, dry, white. Yung iba, yung sagot nyo. Sige nga, I'm waiting for your answers. Okay, so quantitate muna natin siya. Ano siya? Yung growth niya. It's a heavy growth siya. Is it pinpoint, small, medium, large? Pinpoint, small, medium, large.
Pinpoint.
Heavy growth of small. No, this one is considered small. No? I-zoom nyo siya para mas makita nyo maigi. Is it rough, smooth? Paano yung sabi na rough siya? Zoom in nyo ito. No, this one is smooth siya. Hindi siya rough yung kanyang edges. No, kindly check. Paki-zoom in. No, this one is not translucent but it's opaque. white dry colonies, no? Tingnan niyo siya. Blurred siya sa inyo. Okay. Sorry for that. This one is heavy growth of small, smooth, opaque, dry, white colony. Or dry, white colonies, kung mapapansin nyo. Okay. So, next time, hanap tayo ng mas magandang picture. Ito siya. Ito, heavy growth. Ito, hindi. Paano yung quantity? Sige nga, yung iba. Ito, paano nito yung quantity? 1 plus, 2 plus, 3 plus, 4 plus. How about yung iba?
Heavy siya 1, 2.
How about yung iba? 1 plus, 2 plus, 3 plus. Like moderate or heavy. Now, so this one is moderate growth siya, kung i-quantitate natin. Okay? Yes, indeed. It's a moderate growth, of microorganism. Okay, so next i-discuss natin next chapter natin. Hold on for a second. I'm going to upload yung next natin. The PowerPoint. Sige lang, we're going to discuss naman that one sa lecture natin. Magkakaroon tayo ng series of that activity for that. Para mas alam natin later on kung paano siya i-quantitate, paano siya babasahin yung morphological growth ng microorganisms in the culture media. Okay, so hold on for a second, for a few seconds. While waiting doon sa bago natin sa ating chemical identification of gram-negative microorganisms. Dito na natin malalaman, or dito na natin ma-identify or determine yung mga different gram-negative bacilli natin, or gram-negative microorganisms, based on this biochemical identification nila. So we have lots of biochemical identification for us to be able to identify yung mga different microorganisms natin or yung mga different isolates natin in our culture media. Okay? First is we're going to explain the difference between phenotyping and genotyping. Discuss the utilization of lactose by bacteria and compare the differences between oxidation and fermentation. We already discussed this last time. Explain the different reactions that may be observed in the triple sugar ion or yung TSI agar natin. And describe the reactions involved in the products of metabolism. Compare the lead lactose fermenters, or DLFS, and with non-lactose fermenters. And of course, discuss the advantages of multi-test systems. Describe the significance of rapid reporting of bacterial identification, and describe how established manual methods that have been designed for rapid identification of isolates. And of course, we're going to discuss here yung evaluation of the identification system. Okay? Now, first is, ano ba itong biochemical test na sinasabi natin? What are those mga different biochemical tests? Meron tayong mga PSI, LIA, part yun yung mga urate test natin, part yun sila ng mga biochemical testing natin. First is, as what I mentioned last time, this phenotype is usually, is the expression of yung genotype natin. Kung maalala niyo pa during introduction natin to clinical bacteriology, na-mention ko yan sa inyo na that phenotype usually, no, detecting observable or measurable characteristics, no? Or this phenotype is the expression of yung genotypic characteristics of our microorganisms. Okay? When we say serotyping, used with biochemical testing for identifying different strains of bacteria within a species. Now, this serotyping, usually very common, ito siyang ginagawa in our serology. And of course, no, this serotyping is very common siyang ginagawa in our Salmonella species. No? Si serotyping natin. Very common na ginagamit ito with our Salmonella species. No? This serotyping. Okay? So, genotype involves characterizing genes, no? And these genes of microorganisms is expressed in phenotype. No? Yun na yung dinidetermine natin or na-observe natin na characteristics of different microorganisms in our biochemical test and of course, no, in our media plate. Okay? No? Carbohydrate utilization, no? So, na-discuss na natin itong carbohydrate fermentation natin last time, no? Carbohydrate utilization, fermentation, oxidation, no? And saccharolytic, no? So, usually, lactose is the carbohydrate determination test. That is the most important, no? Lactose is utilized through Enden-Meyerhof pathway, no? So as what I remember, discuss nga last time, no? Diba, itong si Enden-Meyerhof pathway natin, no? Na-discuss natin ito or na touch natin kahit papaano. So beta-galactosidase fermase or lactose fermase natin, which serves as the transport enzyme that facilitates entry of the lactose molecule across the bacterial plasma membrane. And this beta-galactosidase, the enzymes that hydrolyzes lactose into glucose and galactose. Now, lactose fermenters, microorganisms, no, they are beta-galactoside fermase plus beta-galactoside, no? Late lactose fermenters, no? They are meron silang presence of beta-galactosidase, and yung non-lactose fermenters, no? Wala silang both beta-galactoside fermase and beta-galactosidase, no? So, yun yung difference ng mga lactose fermenters natin, late lactose fermenters, no? And non-lactose fermenters natin na microorganism. Okay? Oxidation fermentation test natin, no? So, carbohydrate fermentation test natin, no? Meron tayong different carbohydrates na ginagamit. So, later on na i-discuss natin, no? What are those different carbohydrates na ginagamit natin, no? As a form of carbohydrate fermentation natin, no? Test determine the ability of microorganisms not to ferment a specific carbohydrate and incorporate it into our basal medium, no? So, glucose, no, to pyruvic acid, and then magpuproduce siya ng acid or acid with gas, no? So, as what I mentioned last time, during fermentation process, no, na carbohydrates, no, any other form of sugar is i-convert muna siya into glucose, and then after na-convert into glucose is i-convert siya into pyruvic acid, and this pyruvic acid, no, will give us a result of acid or acid with gas formation, no? Doon na natin sila makikita yung end product natin. So, acid formation, no, usually is hemolactic acid fermenter, no? Or mixed acid fermenters, no? Usually, no, yung mga ito yung end product ng fermentation natin, yung mga na-mention natin before ng mga acids, no? Meron tayong product ng homolactic acid fermentation, meron tayong product ng mixed acid fermentation. No, example of the product of our mixed acid fermentation is yung succinic acid natin, propionic acid, and yung lactic acid natin, no? So, as what I've mentioned nga last time, no? During this discussion natin ng ating fermentation and oxidation. Okay, oxidation fermentation test. Meron tayong tinatawag na oxidation fermentation test, no? So usually this oxidation also begins with glucose, no? And entering the glycolysis pathway natin. And this glucose plus yung oxygen natin will convert into pyruvic acid and it will give rise to carbon dioxide natin or CO2. Okay? Now, higher acidity is produced during fermentation than during oxidation. Na-mention natin yan last time, no? And of course, in media that contain large amount of peptones, no? Acid formation may be masked by alkalinity of media. Now, later on, discuss natin yung isa-isa yung mga alkalinity and acidity of different media natin, no? Based on their oxidation and fermentation. Now, oxidation fermentation based on media is simple tawag natin na Hu and Lefson. No, yun yung basal media ng oxidation fermentation test natin na media. And of course, no, this OOF media, usually meron siyang 1% carbohydrates and 0.2% peptone natin or peptone water, no? pH indicator is bronchymol blue and an inoculated medium is green, no? Usually, no, yung OF media natin, no, usually, no, green siya once na mag-produce siya ng acid, yellow, and alkaline is blue. No, ma-identify natin later on, no, based on oxidation fermentation test natin, no, kung anong microorganisms ang magpo-produce ng acid and what are those microorganisms that will produce alkaline based on their oxidation fermentation process, no, or oxidation fermentation test natin, no, based on usually on our oxidation fermentation, no, ito sila ang pinaka-importante, no, yung kanilang acidity and alkalinity of na ipoproduce ng ating different microorganisms. Okay?
Big! Why?
Next natin is no, so ganito siya usually. This one, no, yung ating OF, or oxidation fermentation, no, ito siya. Paano niyo siya identify? Acid, alkaline, or nung wala siyang change? Yung first natin, based on oxidation fermentation natin. Anyone from the group? Ano ito siya? Acid, alkaline, or no change at all siya? No, balikan natin. Kung maalala niyo dito, no, kanina, ano siya? No, ano bang kulay ng ating media? No? Is color green siya usually. And pag nag-produce siya ng acid, color yellow siya. And nag-produce siya ng alkaline is color blue siya. No? So how about this one? No? Ito siya, acid. How about this one? Ano itong color nito? How about this one? May changes? Wala. Okay, wala siyang changes. How about this one? Nagpuno siya ng acid. No? Ito siya, wala siyang changes. Wala siyang changes. No? Later on, makikita niyo kung anong tsura ng alkaline. No? Iti-test natin yan. Okay? Next natin is triple sugar iron agar natin or TSI agar natin or TSI agar natin. No? So, very common ito siya na ginagamit si TSI natin for our gram-negative bacilli microorganisms. No? Meron tayong mga different presumptive, ito siya usually no, useful in presumptive identification of no, yung mga gram-negative enteric bacteria natin. You know, usually, no, si Pseudomonas using this TSI or triple sugar iron agar natin is si Pseudomonas natin usually is nag-exude siya ng alkaline over alkaline. No? Later on, bakit naging alkaline over alkaline siya? Paano natin masasabi na alkaline over alkaline itong kanyang ano tawag dito? Yung pagbasa or kanyang fermentation reaction. Okay? So, TSI, agar, and KIA are useful in the presumptive identification of gram-negative enteric bacteria. No? So, usually, si TSI natin contains lactose, 1%, glucose, 0.1%, and sucrose, 1%. While si KIA natin, no, meron siyang lactose, 1%, no? Si KIA natin. Okay, H2S indicator. Indicator ng ferrous sulfate and sodium thiosulfate. And pH indicator of this media or medium, phenol red, yellow pH no, at 6.8. And the slant portion is aerobic. The butt or the deep portion is anaerobic. So tomorrow, no, i-continue natin ito i-discuss. I'll be showing you different pictures and then you're going to identify if it's acid, alkaline, or meron siyang H2S production or wala. No? So, i-identify natin yan tomorrow. I-continue natin yung ating discussion tomorrow with yung ating TSI-LIA. And of course, no, yung different biochemical test pa na ginagawa natin, no, in identification of our, ano tawag dito, in identification of our different media, no? Pero ganyan siya yung itsura niya, no? But then again, tomorrow, no, i-continue natin yung ating discussion. Okay? So, is there any question before we end with our discussion? Is there any question before we end, no? Before tayo lumipat sa ating laboratory session? Yung iba, may tanong? Wala na? Okay, kung wala na tanong, no, yun na muna for now and see you all again later no, sa lab natin.